Okay, so here's our oscilloscope. For the engineering requirement that the system must have at least 2 functional channels, we do have a channel 1 and channel 2. The channel 2 is displayed in blue here. And if we disconnect the probe, also showing the engineering requirement that we have robust connectors that probes can connect and disconnect to. And then channel 1 here is shown in yellow. As of right now, the trigger channel is set to channel 2. So if we switch that to channel 1, the wave stabilizes. The oscilloscope also has a capable user interface with an adjustable trigger, which locks the wave at the trigger point to the y-axis. You can change the trigger channel. You can change the vertical scaling. And you can change the horizontal scaling. We also have implemented a run stop that freezes the wave. And if we compare to the lab oscilloscope, right now our wave spans about 4 divisions vertically with 1 volt per division. At 1 volt per division, the oscilloscope is also showing 4 divisions. Our horizontal divisions are at 100 microseconds here. The period is roughly 4 divisions.
That's good.
And here we can also see at a horizontal division of 100 microseconds, this is also showing roughly 4 divisions. Now, right now we are in AC coupling mode. I'm going to drop our voltage scaling, and if we do this, now we are in DC coupling mode. You can see that the wave has dropped now, and it is, if I adjust it, centered right between the middle division and the 2 divisions below it. And if we compare to the oscilloscope here, and change scaling, so now we're at 2 volt scaling. This is also ranging from -4 volts to 0 volts. As we can see here, and as you can see, these changes are happening very quickly. There is an imperceptible lag from what we can tell. And currently we are at about 5 kilohertz with this wave. But to show that we have a sample rate of at least 1 megahertz, if we increase,
the PCB works. Oh, sorry.
if we increase our frequency to about 250 kilohertz, at 250 kilohertz, we should be getting at least 4 samples per period. So you can see here, if we are going from peak to peak, we have 1, 2, 3, 4, 5 different samples before the next period starts. So we are above the 1 megahertz sampling rate. We have calculated it to be just over 1.1 megahertz. Currently, the oscilloscope is being powered by 10 volt DC power supply. We also have the engineering requirement that this can accept up to 30 volts safely. So if we change this to 30 volts, you can see that the oscilloscope is still functioning and responding to changes. Just as before.